Okay, so today's lecture, this will be more or less a practice session where I will be just giving you different examples of how to do convolution. As I mentioned last time, we can have more than one way of doing convolution, and we will see that what all different ways are there. At least three different ways we will see, and then it's up to you guys to decide that what way suits you the best. And I will do example with different ways so that you know that there are many ways in which convolution can be done. So initially we will just in this particular lecture we will be concentrating on discrete time convolution, which is a convolution sum. And so till the time we are waiting for other guys to join, we still have at the moment just two guys online. So you two guys, any questions so far? Whatever we have covered in signal and system.
No, sir.
So just a bit of a refresher of what we saw earlier. So let's just start and see. So you see, for discrete time and continuous time, we have difference equation. So looking at difference equation, if you have a difference equation which is given to you something like that, 0.5 x of n minus 0.1 x of n minus 1 plus, let's say, 0.2 y of n minus 1. So for difference equation is given to you. What we have seen so far, that this difference equation completely describes your system, and this is basically an equation which gives you relation between input and output of a discrete time system. So if we are giving x of n as an input, y of n as an output, the relation between x and y will be given by this difference equation, and this completely describes your system, discrete time system. And as I mentioned, we are going to limit ourselves to LTI system. Now, this difference equation which is given to us, mathematicians just see this as a simple equation. They say, okay, fine, we have an equation and it's a mathematical equation, it's a difference equation. But we engineers see this as a system. We just look at it and say, okay, this is a discrete time system. And along with that, we can list down multiple properties just by looking at the system. So in the last lecture we were covering that. So, and I was having a hard time getting you guys to at least answer anything there. So let me try again. So can any volunteer give me properties for this? Any single property starting with first property? So what can we say about this system? Properties. Okay, come on, just any volunteer. So right now we just have around 6 people. Anyone out of you, what can you say about this system?
Sir, this is a stable and causal system.
Okay, you gave me two properties. You said it is a causal system. Very fine. So first property, that this system is causal, and we know there is no n plus any term present. It's a causal system. Second property you gave me was that it is a stable system. First property I agree. Second property, well, with experience I know that's a stable system. I just know from the equation which I have written. But right now the information that you have, using that information, it's kind of difficult for you guys to come up with this property. So any other property? I don't like this property right now. Any other property? So it is a causal system. What else? Okay, let me then give you. Is it an FIR or IIR?
Sir, IIR.
FIR.
FIR.
Okay, I have two people saying FIR, one guy saying IAR. So can anybody, let's say two guys said FIR, can any one of you explain why it's an FIR? Why do you think this is an FIR? What made you say this? Come on, whatever comes in your mind. What made you say it? So just a guess, or you just saw the equation and something struck you? So can you say that this is an FIR? Okay, I think you guys are feeling shy about it. So this is not an FIR. This is IAR.
सर x का of n minus 1 कोई नहीं है इस वजह से.
You see, if we have just feed forward terms, then it would have been FIR. To compute the output, if we just required feed forward terms, then it would have been FIR. But here if you see, we have this feedback term, y of n minus something. If you have even a single feedback term, that makes your system IAR. The impulse response becomes infinite. If this term was not there, then this would have been a FIR system, because to compute output we just required present and past inputs, scaled sum of that. But if you to compute output, you require present and past inputs and also some previous output. This actually is a feedback term. You have to add previous output scaled by some factor and to get your output. So this is a feedback term. Even if a single, then it will make your impulse then so that is why this second property I was not very, you can say, fond of writing it, because IERs can be stable, can be unstable. Okay, so just because of this feedback term, we are not very sure whether it will be stable or not. Although with experience, I know that if the scaling factor is below 1, then most likely it will end up becoming stable. But that is something that you will see in DSP later on. So right now, it will be much easier for us to stick to some basic things, that if it is an FIR, then definitely stable. If IAR, then may or may not be stable. Then we have to check other things to see whether the system is stable or not. Okay, the next one or two properties I can just list down. This is a memory system. Next, it is a first order system. So many things we can just say about the system just by looking at the difference equation. And similarly, for continuous time also, we may have a equation given to us, and looking at that equation, we may actually give you certain properties of the system itself. So let's take a simple example of a continuous time equation also. So for continuous time, typically we have differential equation. So if we have a differential equation given to us, then again looking at the differential equation or equation of the system, we can again list down few properties of the system. Now, the first property that we can list down just by looking at this one is that this is going to be a memory system. So how do we know that your continuous time is memory? If any differential is present. Now to compute differential, differential is basically rate of change. So we need to have some record of previous or past values so that we can find out the rate of change. So that means we have to have some memory present there. Just like in difference equation, you have any difference term that will be that will make your system a memory system. For continuous time, if any differential is present, it will become a memory system. Second, the highest order of differential present is 1. So this is a first order. This is a first order system. Next, if differentials are present only for x terms, then we need to compute rate of change only for feed forward term or for inputs only. But if differential of any output yt is also present, then your system will become IAR. And because this is an IAR, it may or may not be stable, so we cannot really comment on stability. Although typically if there is just first order differential and the coefficient is less than 1, typically it is stable. But again, that also is qualified statement. Right now I will not hold you guys to it. So IAR, if it is an IAR, then you have to be careful about labeling a system as stable or not stable. So it's a memory system, it's a first order system, it's an IAR system. And typically these types of differentials, if you have past values, you don't need any future values for that. So typically these are causal. So continuous time system, at times we can still list down certain properties of the system just by looking at the differential equation. So for mathematicians, that's a differential equation. For engineers, that is an equation which is giving us relation between input and output. So it's a equation which is completely describing our continuous time system. So certain things about the properties. Let me continue. So now let's just, we have ample present now. So let's start with a few examples of convolution. So let's start with convolution, discrete time convolution examples. So convolution, convolution. So convolution actually helps us in finding out output, input and impulse response. So if x of n is given and h of n is given, we can find out output y of n, and this is what we can get through convolution, x of n convolved with h of n. So this is convolution, and as far as the mathematical part is concerned, convolution is basically convolution sum. So this is x of k, h of n minus k. So this is what we know about convolution. It's a discrete time LTI system. So output will be given by this convolution sum. How do we compute convolution? So two methods we have already seen. Now we are going to show you a third method. So first of all, what two methods have we seen? So for example, if we are given x of n, let's start with a very simple example. Let's say 1, 2, okay, let me take one more time, 1, 2, 3. And h of n is also given to you. Okay, so let's take 2 and 1, just two terms. So these two things are given to us, input given, h of n given. Now to find out output y of n, the two methods that we have already seen, one is the basic method, where we just break up your input signals in terms of impulses. So if you break it up in terms of impulses, it will become delta n, 2 times delta n minus 1, 3 times delta n minus 2. And then we can just see that if we give delta n as an input, the output we know is going to be h of n. If we give 2 times delta n minus 1 as an input, output will be 2 times h of n minus 1. And if you give 3 times delta n minus 2 as an input, output will be 3 times h of n minus 2. So if your input is sum of these, output will be sum of these. So we can say that your output y of n is just sum of these quantities, and h of n we know 2 and 1, and shifted version h of n minus 1 will be this thing shifted right by 1 unit and then scaled by 2, and then h of n minus 2 will be this thing shifted right 2 times and scaled by 3. So if we just plug in values for h of n would be 2 and 1, and 2 times this one, 2 times h of n minus 1 will be this thing shifted right by 1 unit and scaled by 2. So shift right will make it 2 and 1, and scaling by 2 will make it 4 and 2. And the third term, it is basically shifted right by 2 units, so double right shift and 2 1, and if we scale by 3 that will become 6 and 3. So your output y of n would be simply equal to, just add all of them together, it will be 2, 5, 8 and 3. So it will be just having these terms, and this will be having 1, 2, 3 and 4 terms. If you see, the number of terms in x of n were 1, 2 and 3. Number of terms of h of n were 1 and 2. So, and in the output the number of terms are 1, 2, 3 and 4. So we can find out that how many terms will be there in output. The number of terms in the output would be the sum of these two terms minus 1. So if you see here, it will be 3 plus 2 minus 1. So this will be 4, and we see 4 terms right here. So it is just for your reference sake, because at times people miss out few terms or just forget to go on and have all the terms computed. So this is the basic method where we have broken down your x of n in terms of delta n, 2 times delta n minus 1 and 3 times delta n minus 2, and just we found out output for each of the input, and if all of them are given as sum as an input, the output would be sum of all these outputs. So we can just plug in values for h of n. This is this, 2 times h of n minus 1, this is this, and 3 times h of n minus 2 is this. We just add them up, we get our answer. So this method is the first method, which is the very basic method that we saw even before we studied convolution. This is indirectly doing convolution, but we can compute convolution by this basic method also, or we can find out output using this basic method. The other method, which we have done so many times, is basically using the equation, convolution sum equation, k equal to minus infinity to infinity x of k h of n minus k. So if we see this, it will, the first thing that we need to know is the limits for this k, where it starts, where it ends. It all depends on this x of k. We know that the terms exist for index number 0, 1 and 2, and before and after this we don't have any value for this x. So it is k is equal to 0 to 2 only. That's the first step, x of k and h of n minus k. That's the first step, and then we can open it up. The first term would be your x of 0 and h of n minus 0. The second term would be x of 1, h of n minus 1. The third term would be x of 2, h of n minus 2. And if you just plug in the values, it would be what? It would be this 1 times h of n minus 0 or h of n, it will be just 2 and 1. 2 and 1. So 1 times 2 and 1. This x of 1 is basically your 2. 2 times this thing shifted right by 1 unit, 0 to 1. And the third one is basically 3 times this thing h of n minus 2 shifted right by 2 units, 0, 0 to 1. And then we just plug in the value and you will see we end up getting the same thing. The first will be 2 and 1, the second will be 042 and third will be 0063. You just add them up and you get your answer right here. So in the summation also, the only catch is right here, that how nicely we can see what all the limits are and then we accordingly open up. We can also write the whole thing in one line once you open the summation, but writing it in multiple lines actually makes it easier to add up. And once we are writing all these things, we have to make sure that they are just aligned together. That way we can just simply add these terms together easily. Otherwise, if you just write it in one line, so it becomes sort of cumbersome adding those terms, and typically that is where most of the students make arithmetic mistake once they are adding these terms together. And if they are writing it in a single line, so at times it becomes, you can say, problematic for them to properly add them together. So okay, so these two methods we already knew it, but I just showed you the same thing again. Now comes the third method of doing the same thing, which will be kind of new to you guys. So let's see that how we can do the same thing. Okay, so let me just write those things again. So this x of n given to us was 1, 2 and 3, 1, 2 and 3, and your h of n was given to us as 2 and 1. And notice that we don't have any indication of indexing. That means the first index is 0 and then 1, then 2. So 0 and 1. So these two things are given to us, and if we have to compute your y of n, then how do we actually compute your y of n? Now y of n we know is going to be a convolution sum, k equal to minus infinity to infinity x of k h of n minus k. So we saw we can just directly apply this formula and get your results. Now comes another interesting factor right here. And this is the third method that we will see, that how we can compute convolution. So if you see this n right here, this n is here and here. Now if you want to compute y of 0, this will be summed for all x product with h of 0 minus k or minus k. You can say just 0 minus k. Y of 1 would be this product sum for x of k h of 1 minus k. And maybe we can keep going on like this. So in general we end up getting y of n is basically sum of x of k with h of n minus k. Typically this is what we are doing. So individual terms we can find out the value doing this. So this is sort of the theory base for what we are going to do right now. So the product of x of k with h of minus k. Now what we can do is we can make a table. Let's make a table. And in the table let's have values for so let's have values for k 0, 1, 2 and 3, and we can keep going on if you want to. And let's write x of k. So x of k, we can write here x of 0 is basically 1, x of this is 2 and this is 3. Now let's just continue writing, and let's just write h of minus k. H of k is 2, 1. H of k would have been 2 and 1, and h of minus would be this thing flipped. So if this thing is flipped, 2 remains the same place and this will be at 1. This is h of minus k. And similarly we can write the term h of 1 minus k. So if we flip your axis, h of minus k is this, and then we add anything. 1 minus k will be this thing shifted right by 1 unit. So this will be 1 and 2. So h of 2 minus k, we can just plot that also. This will be 1 and 2. And similarly, we can just continue and plot for other terms right here. This is going to be your h of 3 minus k. This would be 1 and 2. And this about sums up the whole thing. Okay. So in this method, we need to just fill in this table. Now, if you notice, this is h of minus k, just like we have this summation here, and this is related to the n that we have. Y of n, where n is 0, will be this. Y of n, where n is 1, is this. So k is sort of here. If we write n here, this is basically for n is equal to 0, 0 minus k. You can think of this as this way. This is h of n minus k, where n is 1, n is 2, n is 3, something like that. Okay, so y of 0 is basically product of x of k with h of minus k, for 0 minus k. This with this. And we can just write your y of n this way. So y of 0 would be product of this with this. And this is basically a dot product. So dot product, we just overlapping terms we multiply. So here we end up getting the value 2. Here, if we just want to fill in, there will be all zeros here. So all other terms are actually 0. Just these two terms are overlapping. So dot product will be 1 and 2. It will be just 2 here. And similarly, we can just keep plugging for other values. So let's do this other one for n equal to 1. This will be h of 1 minus k with x of k, h of 1 minus k with x of k. If you see, we have two overlapping terms. This will become 1 into 1 plus 2 into 2. So 1 plus 4 makes it 5. We end up getting factor 5 right here. And similarly, if we see the next term where n is 2, it will be this multiplied by this. Here we have two overlapping terms again, 2 multiplied by 1 plus 3 multiplied by 2. Okay, so can you guys hear me now?
Yes, sir.
I'm sorry, it had an internet breakdown here, so let me again start with that methodology again. So let's continue. Okay, so what we had was a table for k, and we had k equal to 0, 1, 2, 3, 4. And on this side, we had a plot of x of k and h of minus k. So, and then plugging in the values, this was minus 1, minus 2. So x of k, it came directly from what we had for x of n. The question given to us, it was 1, 2, and 3. And h of n, the question given to us, it was basically 2 and 1. And we had to find y of n. And we said that, well, let's do it in a different way. So this method, we just labeled this method as method 3. And this is basically h of 1 minus k, 2 minus k, 3 minus k. We just do this. Okay, so if you just plug in the values, this is 1, 2 and 3, and h of minus k, this is h of n, so h of minus n or h of minus k would be this thing flipped. This will become 2 and 1 with the arrowhead right there. Or in other words, this was your h of n, this was basically 2 and then 1. This is your n, this is your h of n. And if we want to do the flipping part where we want to plot h of minus k on the k-axis, so this will be 2 remains as it is, this becomes 1, minus 1 and 0. So this is what we have done. H of minus k would be the flipped version, 2 remains there and 1 comes right here. And h of 1 minus k would be shifting this right. It will become again 1 and 2 with arrowhead coming right here. In other words, it would be thing shifted right by 1 unit. This will be your h of 1 minus k. H of minus k shifted right by 1 unit. So this will be 1 and 2, and similarly 2 minus k will be 1 and 2 here, and 3 minus k will be 1 and 2 right here. Now till what time do we need to keep shifting? That's a thing that we need to know, that why did we really stop here? Because if you see the overlapping terms, if I had plotted your x of n here, you will see that this will have single overlapping term, this will have 2 overlapping terms, and this will continue like this. You can see here. So h of minus k and x of k, it has 1 overlapping term. Here you have 2 overlapping terms, again 2 overlapping term, single overlapping term. If we write another term right here, it will be just no overlapping term. So we just shift till the time we keep getting overlapping terms. And we can directly write your, this is kind of related with, and this is k factor right here, and this is more or less the n's coming here, 0, 1, 2 and 3. So we can write your y of n simply. The first overlapping term that we get is for n equal to 0. At n equal to 0, h of 0 minus k and x of k has 1 overlapping term. So y of 0, the term that you get here, is basically 2 dot product. This multiplied by this and added to all zeros. Then for n equal to 1, this is this with this 2 overlapping terms. N equal to 1, typically we write it here at 1 index. So 2 overlapping terms, it is 2 multiplied by 2 plus 1 multiplied by 1, this makes it 5. Then the next one, we just have 2 overlapping terms again. This is going to be 3, 2, 6, 7, 8. 8. 3 times 2 are 6 and 2 times 1 are 2, so it makes it 8. And the last one, we have this overlapping with this, just 1 overlapping term, this is 3. So y of n is just 2, 5, 8 and 3. And the indexing part for y of n, this is n equal to 0. N equal to 0 term. This is n equal to 1 term. So that's why we typically write it this way. At times people just write y of n here, and just at times people write y of n here also and just do it this way. Or you can do it here. So this is the third method, where we actually write one term as it is, the x of k part. The other term we flip and then shift. So this is at times referred to as flip and shift method. Flip and shift method. At times people call it as tabular method also, that we actually make a table and then do the whole thing. Now this method, at the very first look, the first time it is introduced to students, they find it kind of more cumbersome. They think that maybe that summation part or the basic method is kind of simpler. But with experience, I have seen that almost all the students end up resorting to this tabular method later on. And there are multiple reasons why this tabular method is much simpler to deal with. And the first one, you can't really make mistake if you just fill the table right and then just do the dot product right. You can't really make the arithmetic mistake because everything is just in its place. Uh, the second the second strong point of this method is if you have large number of terms, and typically if you have two-sided terms. Here both x of n and h of n had indexing starting from 0. If you had indexing starting from -2, -4, whatever, then filling this table accordingly and dealing with that will be much simpler in comparison to other methods that we have seen. Now to show you the benefit of this, I will show you a method where we actually use that thing. Okay, so let's just do a few more examples which will actually explain that why this is method of choice for most of the students and why people tend to prefer this. Now let's take I will not call it complicated, but a bit different example. If x of n is given to you as this 2, 1, 2 and 1. So this is -2, -1, 0 and 1. So this is your x of n given to you. And let's say your h of n is given to you as, let's say 1, 2 and 1. -1, 0, 1. This is n. So h of n and x of n are given not in terms of values, in terms of graphical representation. Now from this graphical representation we can actually write x of n as 2, 1, 2, 1. But because your 0 is right here, we have to put a arrowhead right there. And this is the latest convention, as I mentioned, although we can just write -2 here, that will also be the same thing. So we can write this way, or h of n, if you want to write similarly, it will be written as 1, 2 and 1 with the arrowhead right there. So if you have to find out your convolution sum for this, or output for the system whose input is this x of n and impulse response is h of n, and if you have to find out your output, then how do we find this? Again, we can do it in all three methods. This also we can break down in impulses and see the result, and again we could have just used the summation and still seen how the result is going to be. But let's just do the tabular method. So if we have to make a table for this thing, let me try to make a table for this thing. So values of k, 1, 2, and we can keep going on, and value for x of k. If you see, x of k values are having indexing at -1, -2 also. This is 2, 1, 2, 1. Now comes the interesting part. Once we try to write the values for h of -k, the flipped version. Flipped version is also the same as the main version, because if you flip it, you end up getting the same thing back. So 1, 2, 1. So it will still be 1, 2 and 1. So this is your h of -k. Now comes the interesting part, because if you see here, we already have 1, 2 and 3 terms which are overlapping. Now to start, we need, where should we start your n from? This is n equal to 0. At n equal to 0, or y of 0 already had 3 terms overlapping. Now instead of just shifting these terms right, we have to start from value where we have just one overlapping term, 1, 2 and 1. We have to start with from this. So this should have started from here. Now if this is h of minus k, you shift it left by 1, this is going to be h of minus 1 minus k, minus 2 minus k, and this will be h of minus 3 minus k, h of minus 3 minus k, because this is h of k shifted left by 1, 2 and 3 units. So this is what we have. So this is your h of k or h of minus k shifted left by 3 units. So this is your n equal to 0, this is your n equal to minus 3. So we should have started from this point and then moved forward. So if we just now keep shifting, let's see that what we end up getting. So this will be 1 to 1 here. So this will be again 1, 2 and 1 here, 1, 2 and 1 here, and this is coming back to your original location, and it will keep going on and on and on because we had so many terms. So let me just first complete this. This is going to be 1, 2 and 1. So if we just keep writing this, this is minus 2 minus k, this is going to be h of minus 1 minus k, this is going to be h of minus k or 0 minus k, this is going to be h of 1 minus k, h of 2 minus k, and this is related to your values of n. So minus 3, minus 2, minus 1, 0, 1, 2. Okay, we end up getting a table right here, and then we can write your y of n for n equal to where. So we see the overlap actually starts from n equal to minus 3. So at n equal to minus 3 we have single overlapping term. This is going to be 2 into 1, and this is going to end up giving you value 2. Notice where we are writing it. Notice where we are writing it. And again the next term, we are having two overlapping terms. 2 into 2 plus 1 makes it 5. Next we have 3 overlapping term. We have 2 plus 2 plus 2 makes it 6. Next we have at n equal to 0, we have again 3 overlapping term. This is 1, 4 and 1 makes it 6 again. Okay, so again here we have 2 overlapping terms. This is 2 plus 2 makes it 4, and the last one we have just 1 overlapping term. 1 into 1 makes it 1. So we can write your y of n as being equal to 2, 5, 6, 6, 4, 1, and the arrowhead here, arrowhead where your 0 value is, and the total number of terms. If you count, in x of n we had 1, 2, 3 and 4 terms. In h of n we had 1, 2, 3. So total number of terms that y of n or output should have would be 4 plus 3 minus 1. That's make it 6 terms. If you see here, 1, 2, 3, 4, 5, 6 terms. So this is this method where we actually cater for the negative, positive, and if you have large number of terms. Now if you see, we again started by the same set of rules. We made a table, we plugged in the values for x of k, which was 2, 1, 2, 1, plugged in value of h of minus k. So h of k was given, h of minus k is flipped version, and the flipped version with the axis is actually flipped. It came out to be 1 to 1. But once we wanted to continue, we saw that we already have 3 terms which are overlapping, and actually we had to start from this very point. So we had to actually shift this h of minus k to 1, 2 and 3 positions left. So 3 minus k, or n equal to minus 3. So this actually tells us that once we are finding out y of n, which is sum of uh, x of k, h of n minus k, and this is k equal to minus infinity to infinity. So we need to know that from what point this thing starts. We saw here that values start from y equal to minus 3 and then y minus 2, sorry, y minus 2, and then it was just continuing, and it went all the way to y of 2. We had values for all that. So this is the third method which we actually saw, example 2. And if you just do the same question, if we do the same question uh, a bit other methods, let's do the same question where we are given, let's say, x of n, which was 1, 2, 1, 2, and we had been given h of n, which was basically 1, 2, 1. Okay, and arrowhead right here and arrowhead right there. So if we were given this, check 1, 2, 1, 2, 1, sorry, and 2, 1, 2, 1. Let me correct it. This one was 2, 1, 2. So this was that question, and if we had to do it in our own method of convolution, it would have been this convolution sum, k equal to minus infinity to infinity, x of k, h of n minus k, and then we had to cater for the limits part. So x of k, now k started from, this is minus 1 minus 2, from minus 2 till 1. It will be k from minus 2 till 1, x of k, h of n minus k, and then we can just open it up. So it would be x of minus 2 into h of minus 2 minus k. So whatever that will be, and plus then it will be x of minus 1, h of n minus k. I'm wrong, this is not right. X of k, h of n minus k. Now it's right. N minus k is this plus x of 0, h of n minus 0, which is n. Okay, and we have then x of 1, h of n minus 1. So this is what we have, and then if we plug in the values, so x of minus 2 is 2, so 2 times h of n plus 2, this is h of n, so h of n plus 2, it will be this thing shifted left by 2 units. So if you shift it left by 2 units, we end up getting what? 1, 2, 1, and this is shifted left by 2 units. Arrow was originally where? Here, and if we shift it left, so then we need to put a 0 right there. This is what we are going to get, because let me just show it here. So we had 2 and 1 and 1. This was your h of n. So h of n plus 2, this will be this h of n shifted left by 2 units, shifted left by 1, shifted left by 2. This is going to start from here. So this will be your -1, and then we have 2, and then we have 1 again. So -3, -2, -1. So this is 0 right here. So if we have to show it here, the arrowhead will come something like this. So this will be x of -1, which is 1, into h of n plus 1. So this thing shifted left by 1 unit. So this will be 1, 2, 1, and arrowhead right here. This will be x of 0, which is 2 times h of n, which is same as your 1, 2, and 1, and x of 1, which was actually 1, and this thing is shifted right, so this will make it 1, 2, and 1. So the blanks, we can just fill up the blanks with zeros, so we end up getting something like this. Now we need to just do the maths and get your answer. So if I just do the maths, I hope I do it correctly. So it just comes out to be, the first one will be 2, 4, 2, and 0, and the second one would be same 0, 1, 2, 1. Third one would be 2 zeros, and then 4, 2, 4, and 2. The last one would be 1, 2, 3 zeros, and then 1, 2, 1. And if we add all of them up, let's hope we get the right answer here. So this is 2, this is 5, this is 6, this is again 6, this is 4, and this is 1, and our arrowhead is basically here at 0, at this point, at this point, at this point, so at this point. So this is your y of n. And if you compare it with what we had done earlier, you will see that we had the same result earlier. So we had this result, and previously we had the same result, 2, 5, 6, 6, 4, 1. And we have 2, 5, 6, 6, 4, 1 with arrowhead on 6, with arrowhead on 6. So this tabular method at the very first introduction seemed cumbersome, seemed more complex, but if you see here, if you have to do all this alignment and all this multiplication and then getting the same result, and again right now we have just 4 and 3 terms here, and total number of terms are 6. Let's say if we had 5, 6 terms here and 4, 5 terms here, and we had all positive indexing, then keeping track of all those indexing and keeping track of what is shift left, what is shift right, that at times becomes very cumbersome. But if you do it this way, just write first term as it is, second term flipped, and see where that overlap is. And then if we are already having overlap, then we just shift it left till the time we have just single overlap. So how much shift left we want? It is going to be this way, and then accordingly we put the index n for that, and then we can just keep going on. And if you see, the first overlap starts with n equal to -3. So it is h of n minus k, so h of -3 minus k. This is that term being multiplied with x of k. So x of k with h of -3 minus k. So this is what we are multiplying with the very first term right here. Just so in this we are taking dot product of x of k with h of -3 minus k. So this product dot product is going to give you your y of -3. So we just write your value of y under your -3 thing. So y of -3 would be h of -3 minus k with x of k dot product, and we get our result here. The second one was for n equal to -2. So it will be h of -2 minus k with this thing, and we just keep going on till the time we have the last one. At the last one we have n equal to 2. N equal to 2, this is h of n minus k, so h of 2 minus k with x of k. We have just one overlapping term, and that gave you your n equal to 2, y is of 2. So from this point till this point, from n equal to -3 till n equal to 2, 6 terms. So this is that third method that again I need to reduce. So I will just take about 5 minutes break. So go through this slide and see if there are questions and you're still not clear that how did we do that. I will just come after break in about 5 minutes and we discuss that. Okay, so let's see what we have. Any questions? This flip and shift or tabular method. Any questions in this one? So we saw that how we can actually use that flip and shift method and solve if we are given x of n, if we are given h of n. All we need to do is write x of k, write h of minus k. So if h of n is this, h of minus k is this. So this is for k equal to 0 it is 2, k equal to 1 it is 1. So this is k equal to 0, 2, k minus 1 is 1. So and we see just overlap terms, just one term, and then we just shift and keep shifting till the time we have overlapping present. And after this, if we shift further, the overlapping will stop, so we just stop right here. So we just keep shifting, and this is h of minus k, or in other words 0 minus k. This is h of 1 minus k, this is h of 2 minus k, h of 3 minus k. So this is, in this side we are actually writing h of n minus k, so n0, so n1, n2, n3. And that actually helps us finding out our y of n. So y of 0 would be h of 0 minus k with x of k. So these two terms together, so y of 0 would be this with this. Y of 1 would be for this h of 1 minus k with this dot product. We just write the values here. We keep writing, and that is what we end up getting here. So this was straightforward, where there was no you can say speciality involved, and all these terms that we had, x of n and h of n, they were both right-sided. So nothing on the left-hand side. And in the next example, we actually saw that if we have the two-sided or terms where we have values on negative side and positive side both for x of n and for h of n, then how do we deal with this thing? Then in this we saw, again we just make a table and just fill the values for x of k and h of minus k. So this was your h of n. So h of minus k would be the same thing flipped. Again we'll give you the same thing, 1 to 1. We saw that we already have 3 terms overlapping, so we had to start from this value 1, 2 and 1. So this 1, 2 and 1 written this way would be this h of minus k shifted left by 1, 2 and 3. shifted left by 3. So this is h of minus 3 minus k. So in other words, this column is actually showing you h of n minus k. So n equal to minus 3 would be h of minus 3 minus k. So n minus 2 will be h of minus 2 minus k. So this is this, and we keep writing this shifted terms till the time we have any overlap present. And after that, if we had shifted further, the overlap with x of k would stop. So we just stop here, and this is for n equal to 2. And then we just start solving for your final answer for y of n. So for n equal to minus 3, n equal to minus 3, it will be h of minus 3 minus k, this one, with x of k, this one. And similarly, we just keep doing the dot products and we end up getting our answer right here. So this is the flip and shift method. And the same method, and the same question, if you solve using your second method, which was simply application of formula, this is what you will end up getting, and we end up getting the same answer right here. The number of terms in the answer after convolution, the number of terms are actually going to be sum of both the terms minus 1. So total number of terms in x of n were 4, total number of terms in h of n were 3. So total of these two came out to be 7, and in the answer the number of terms should be 6. 7 minus 1. 1, 2, 3, 4, 5, 6. So we actually saw that how we can actually get your result doing this. Okay, so let's just see that what we have. So far we have seen three methods. The first method of convolution was the basic method where we actually converted your input x of n. X of n was converted into set of impulses, or set of or sum of impulses, and then saw the response for each individual impulse, and then just added up all the result together. Second, we actually used your formula, convolution sum formula. In the second one, we actually used your convolution sum formula, which was basically this: k equal to minus infinity to infinity x of k h of n minus k. We just plugged in the value and mathematically solved it. Third method was, we can call it a tabular method. Tabular method, or we can also call it as flip and shift method. So we saw three methods. Now, which of these methods are, you can say, recommended, and which one should you use? As far as I'm concerned, in whatever course I teach, I don't limit you to any particular method. So whatever method suits you, I will never specify. Whatever midterm and term assignments that you are given, I will never specify that do it by this method or that method. It's up to you. Whatever methods you find convenient, you can use that method and give me the result. As long as you give me the right result, it's fine with me. It doesn't really make any difference. Now, again, apart from these methods, you will see multiple other methods which are shown in, you can say, courseware that you can access from Google, MIT courseware, Stanford courseware. And there are multiple YouTube videos which actually gives you multiple different methods of doing convolution. All of them are having the same theory based on the same convolution sum theory. So as far as I'm concerned, if you use any particular method as long as it is the right method and giving me the right result. I don't have any problem with that. The purpose of this course is actually to make you comfortable in a situation where you are given an input and you are given an impulse response and you have to find your y of n, and we know that y of n is basically convolution. And this convolution order also we know doesn't really matter. You can take h of n first, x of n first, it's up to you. You can use any of these three methods or any method that you come across in any of the books, in any of the videos, in any of the sites that you may refer to. So the main thing is that you should be comfortable doing convolution. As an engineer, in the real world, the problems are there for you to solve. Once you go out in the field and come across a particular problem, then that problem is not going to say that solved by this method or that method. As an engineer, you have to engineer the solution. You have to come up or engineer the solution for that. And whatever is the simplest and easiest method, that is something that you should just engineer the simplest and the best solution for that. Now, for one person, one method may be better than the other method depending on his particular expertise, his particular practice, or his particular liking. So that is why I don't really limit you to one method or the other method. So be comfortable with all these methods, and if you come across any other also, go ahead, use that and just see that what suits you. So any question on any of these methods? Are there any questions here? Okay, so if there are no further questions, let me just continue and just see that what we have further. Okay, so this was as far as the discrete time was concerned. Now we have similar situations for continuous time also. In continuous time, once we have to do convolution, for continuous time, if you have to do convolution, you would be given x of t and you would be given h of t, and you have to find your y of t. Y of t we know is going to be the convolution of x of t with h of t. And for continuous time, this is going to be the convolution integral x of tau h of t minus tau. Now, how the x of t is given to you? It may be given in multiple different ways. Till now, what we have seen is we were given x of t in shape of some equation or some, let's say, function, and then we could simply use that integration, plug in that function value here and just solve for that integral. The same methodology that we saw, that flip and shift, is valid for continuous time also, and that becomes very useful, especially if you're given the problem in, let's say, graphical shape. If you're given the problem in graphical shape, let's say from 0 to 2, this is your x of t, and if we are given, let's say, h of t, which is okay, let's make a triangular thing. So 0, 1 and 1, and this is your h of t. If we are given this way, now we can come up with a function for this, write it as a function here, and then put the value of function inside the integral and solve for that integral. We can do it this way, or we can do another interesting thing. What we can do is we can just use that flip and shift method. This is basically 0 and 2, your x of t, or if it is tau, this will be tau, and if we just flip your h and write h of minus tau. So this will become something like this. Now if we just start shifting, the shifting would be something like this. It will be just going and going. Now this point that you see here, this is 0 minus tau. If we just take this point as t, if you just take this ending point as t, this is t equal to 0. This is for t equal to 0, and we can say that this is the graph of t minus tau. So here for t greater than 0, it will be for h of t minus tau, and we can then have a graph for this is again t, this is again t, and we can have a situation where it has crossed this t greater than 2. So if you see overlap 0, we have overlap portion, which is this one. We have overlap portion, which is the whole thing. Here t would be equal to, if I'm not wrong, it should be equal to 1. And if we have this t greater than 2, it will be something like this. So overlap portion, this one, and here there is no overlap. And then accordingly we can come up with value for your output. So if we want to plot your y of t, we can plot your y of t. Y of t is basically this. It is product of x of tau and t minus tau. X of tau and h of t minus tau product. Once t is less than 0, the value will be 0 throughout. And as we start moving in this domain where t is greater than 0, you will see that we'll start having this overlap. Now if this value is 1 right here, then whatever is the area here gets multiplied by this, and you will end up getting the area, and you will end up getting a plot, and that plot actually finishes once the overlap finishes. So it will have a particular sort of a shape, and this will become 0 right here. So in between whatever is the shape, again with experience you can just see that what that shape is going to be. So we are going to have an area which is going to keep increasing, and become maximum at t equal to 1, and then from t equal to 1 till 2. This will be having a constant value, so it will just exceed, and then from 1 to 2 it will have a constant value, and then once it starts going beyond 2, the maximum you will have at 1 and remain constant till 2, and then after 2 it will again fall, and it will finish once t is equal to 3. Something like this. The shape that you will get will be something like this. So this is just, you can have a sort of a feeler that the flip and shift method is more of a graphical thing. Now there are multiple videos which are available which actually shows you that how this flip and shift method is graphically used for continuous time. So we can also come up with an equation for these functions, write those equations there, and then break up these equations into different, let's say, parts where t is less than 0, Then what happens? T equal to 0, what happens? T greater than 0 and between 1, what happens? And then equal to 1, and then it just goes on and on and on. So we can just see that what those values are going to be. But practically, you will see that it will end up giving you something like this: exceeding, reaching a maximum, remaining there, and then becoming minimum again. So it will reach maximum once t is equal to 1, retain that maximum value till 2, and then from 2 to 3 it will just die down to 0 again, something like that, up, constant, and down, because this is basically multiplication of the two areas. So practically, if you see the overlap part, if this is overlap part, it is going to overlap from 0 to t. So this area will be 1 multiplied by t, and this area will be that triangular area. So we can just see that plot, that how that plot looks like. We can come up with the equation for this plot. This max value, we can find out that max value, it will be that triangle which will be from 0 to 1, that triangle area, which should be equal to 0.5 if I'm not wrong. So 0.5 will be area of triangle multiplied by this 1. It is, and 1, still 1, so this is going to be 0.5. The max value will be equal to 0.5. And maintain that and then die down again. So this continuous time graphical representation of flip and shift method, I've tried to depict it right there. But again, it was for at least this continuous time. In this course, you'll be mostly or almost always given the formula or expression for this x of t, and similarly for h of t. We can very easily plug it here and just solve the integral and find out the result for y of t. But if you want to know the shape of that thing, if you know how to plot that function, you can just flip the second function and then shift and keep shifting till the time we have overlap. And once overlap stops, that means now you don't need to shift further. So this was for continuous time. Okay, so let's just see that what we have in store further. Before we continue, rather I should just stop. I don't want to go further because it will just take us to the other topics for this course. Till this time we have covered convolution, and we have concentrated more on discrete time convolution, and we have seen multiple methodology of doing discrete time convolution. Continuous time, although I did explain this flip and shift graphically for continuous time, but mainly we will limit ourselves to convolution using convolution integral. Any questions? So if there are no further questions, then let me just so that will be all for today's lecture. Okay, so we saw that out of multiple properties, the important properties, two important properties were there. One was the causal property, because real world systems are all causal. If you have to patch up or make a physical circuit, it has to be a causal thing, because all real world systems are causal in nature. The second important property is that of stability. If your system is not stable, there is no point making a circuit out of it, because you will see that the output will end up being saturated. It will tend to go towards infinity, and theoretically it will go infinity, but practically you will see that once you patch your circuit, whatever input you give, it will just max out, it will just saturate. There will be no output, it will be just same as VCC, same as input supply. So making or patching unstable circuit doesn't make any sense. It is just waste of time. So if you have designed a particular circuit, two properties are important for us. So once we say you have designed, that means you have come up with some equation for a particular circuit or a system. Then we have to see whether that particular equation is causal. And second, we have to see whether we can actually make it, whether it is stable or not. And if it is not, then there is no point making it. So these two properties are important for us, and other things, well, how's the functionality and all that, that you're going to cover in detail in your DSP course. So I will just stop here and we will continue next time.